Welcome to a time when machines were built ahead of the world. Too strong, too simple, too perfect. The future wasn't ready for them. While others failed, these kept working. Decades later, they still do. This isn't history, it's proof. Number 1. Vermeer's large round baler. Perhaps no single hay machine from the 1970s had a more transformative impact on forage production than the large round baler introduced by Vermeer. Before Vermeer's invention, hay was predominantly gathered into small square bales, typically weighing 50 to 100 pounds, which were manually handled in fields and stacked by hand. This method was labor-intensive, time-consuming, and became increasingly impractical as farm sizes expanded after World War II. Then, in 1971, Gary Vermeer of Pella, Iowa, engineered a new type of baler capable of producing very large cylindrical bales, and by 1972, the Vermeer 706 large round baler was being sold commercially. The reason this machine was too good for its time lies in what it enabled. Round bales produced by the Vermeer baler weighed well over 1,000 pounds, often up to 2,000 pounds, and were much larger than the traditional small square bales. This wasn't merely a marginal improvement. It fundamentally changed how hay was harvested, stored, and handled. A single operator could now produce hay with far less labor and time, drastically improving productivity on larger farms. The larger bale size also reduced exposure to spoilage because round bales shed water more effectively than loosely stacked square bales, improving feed quality. The baler's design, employing a belt system to roll hay into a tight cylinder, became the foundation for virtually all large round balers that followed. Independent recognition of the machine's historical importance came decades later when the American Society of Agricultural and Biological Engineers, ASABE, designated the Vermeer large round baler as an engineering landmark. The ASABE cited its impact on reducing manual labor and transforming hay production workflows. There's also an interesting economic dimension. In the early 1970s, many farms were still relatively small compared to later decades. Investing in a baler that dramatically increased capacity was a bold choice at the time, partly why it took years before round balers became commonplace. But that early adoption curve didn't diminish the technology's influence. Instead, it foreshadowed the rise of mechanization that would define modern agriculture. In short, Vermeer's large round baler didn't just solve a problem farmers were facing in its own decade. It shaped how hay would be harvested for generations. Number 2. International Harvester 400 cyclo planter. Another 1970s machine that proved to be ahead of its time was the International Harvester IH400 cyclo planter, first introduced in While not as glamorous as a massive baler or power pack tractor, the cyclo planter brought a technological leap forward in how seed was metered and delivered into the soil. The core innovation lay in its air-assisted seed metering and delivery system, a design first envisioned by the Losek brothers and adopted by IH engineers in the late 1960s before being commercialized in the early 90s. Traditionally, seed planters used mechanical seed plates, metal discs with holes sized for specific seed types to meter seed. This meant that switching to different crops often required changing plates, and seed delivery was susceptible to variability. The cyclo planter's design used central seed hoppers with air pressure forcing seeds through tubes to individual row units. This air-assisted metering allowed seed to be delivered more smoothly and consistently, regardless of seed size or shape. In a field where uniform seed spacing and depth translate directly to plant population and yield potential, this was a true technical breakthrough. The impact in the field was immediate. Sales outstripped initial demand, forcing IH's Canton, Illinois plant to operate around the clock to meet orders. That's rare for a piece of equipment whose underlying innovation was fundamentally scientific rather than simply bigger or more powerful. The cyclo design was not perfect. Early units did have limitations in certain soil conditions and spacing consistency compared to later planters, but its core concept endured. Today, most modern planters and drills use air or vacuum systems inspired by the cyclo concept to meter and deliver seed precisely and reliably. What made the 400 cyclo especially ahead of its time is how quickly its core idea was adopted. Industry-wide, planters of the late 1970s and early 1980s increasingly incorporated air assistance or vacuum seed meters, especially as farms grew and the need for planting precision mounted. The cyclo also influenced the design evolution that eventually led to high-speed precision planters, GPS offset placement systems, and the variable rate seeding technologies that now define modern precision agriculture. In other words, while the 400 cyclo might seem rudimentary compared to today's billion-dollar planting systems, its introduction marked a pivotal point where seed delivery became an engineering problem to solve, not just a mechanical necessity. Number 3. John Deere 7000 planter. In 1974, John Deere introduced its 7000 series planters, including the 7000 and the 7100 Max Emerge models. These planters were not just incremental improvements, they signaled a paradigm shift toward precision seed placement that would become a hallmark of modern row crop production. While seed placement and spacing might seem like straightforward tasks today, achieving accurate seed depth and uniform spacing at speed was a real challenge in the early 1970s. Deere's 7000 series tackled that challenge by integrating several new technologies that together raised the standard for field performance. One of the key innovations in the 7000 series was the True Viprumi opener system. Unlike earlier planters that used flat discs or simple furrow openers, the True Viprumi system used angled disc blades that cut a consistent seed trench with minimal soil disturbance. This improved not only seed depth control but also seed placement consistency, essential for uniform crop emergence. Accurate depth placement is especially critical for crops like corn and soybeans, where emergence timing can greatly affect yield outcomes. Another major advance was the planter's ability to maintain consistent seed depth across variable field conditions. Many earlier planters relied on operator skill and guesswork to set depth, often resulting in uneven stands. The Deere 7000's engineering gave farmers a much better chance of achieving uniform rows at planting speeds that were increasing alongside farm sizes. In doing so, it helped shift the mindset of growers from just get seed in the ground to get seed in the ground right. That distinction from mere planting to precision placement would influence decades of subsequent innovation. The success of the 7000 series is evidenced by its manufacturing lifespan. Deere produced it from 1974 through 1986, a long run that reflected strong market acceptance and significant technical demand. Many agricultural historians and machinery records identify the 7000 series as the machine that helped Deere dominate the planter market because it combined reliability with performance that older models couldn't match. Over time, features first seen in the 7000 were enhanced with hydraulic downforce controls, row-by-row monitoring, and GPS guidance, but the core principle of precision seed placement remained rooted in what Deere introduced in the 1970s. In essence, the John Deere 7000 series didn't just plant seeds, it planted the concept that accurate, consistent seedbed preparation and placement trump raw speed or size alone. That shift in thinking ultimately helped pave the way for today's precision agriculture era. Number 4. New Holland TR70 Twin Rotor Combine. The New Holland TR70 Twin Rotor Combine, launched in 1975, stands as one of the most forward-looking harvesting machines of the 1970s because it introduced a fundamentally different approach to crop threshing and separation. Prior to the TR70, most combines relied on a conventional system consisting of a threshing drum followed by straw walkers. Crop material entered the machine, grain was separated from the heads by the drum, and then the remaining straw was gradually shaken out by a series of walkers. While this system was effective, it had limitations in throughput, grain quality at higher speeds, and overall efficiency in heavy yield conditions. New Holland's solution was radical for its day. Instead of threshing and then separating through a series of discrete steps, the TR70 used two longitudinal counter-rotating rotors to continuously process crop material. Grain was threshed and separated along the length of the rotor path, allowing for a smoother, more continuous flow of material through the combine. This design reduced mechanical complexity, improved the uniformity of material handling, and increased harvesting capacity, all in a package that could outperform traditional combines in demanding field conditions. The twin rotor concept was not merely about capacity, though that was important. It also improved how crop material was treated inside the combine, leading to better grain quality and reduced losses. Because the rotors processed material in a continuous, less disruptive flow, kernels were less likely to be damaged, and foreign material was more reliably separated before cleaning sieves. These operational advantages became increasingly important as farm fields expanded and crop yields rose throughout the 1970s. What makes the TR70 especially ahead of its time is that it didn't remain an isolated experiment. It became the progenitor of a harvesting system that would define New Holland combines for decades. The twin-rotor architecture evolved into what many producers now recognize as New Holland's signature harvesting approach, continually refined with advanced cleaning systems and electronics, but rooted in that 1975 breakthrough. For many farmers, adopting a TR70 meant they could harvest more acres per hour without sacrificing grain quality, a clear performance edge during tight harvest windows. In the broader historical context, the TR70's twin-rotor design pushed the entire combine industry to rethink what harvesting machines could be. Other manufacturers eventually explored their own versions of continuous flow threshing systems, and today's high-capacity rotary combines, including those from competitors, trace conceptual heritage back to innovations like the TR70. In this way, the TR70 didn't just harvest grain, it harvested a new future for combine performance. Number 5. International Harvester Axial-Flow Combines. In 1977, International Harvester IH fundamentally changed how combines worked with the introduction of the first axial-flow rotary combine harvesters, an innovation that reshaped harvesting technology for decades. Before this development, combine harvesters, the machines that cut, thresh, and separate grain in one continuous process, used the traditional drum and straw walker system. In that setup, crops were threshed by a rotating cylinder and then gradually separated from chaff and straw by a series of vibrating walker platforms. While effective, this design had limitations. Capacity was constrained, grain quality could suffer, and the machinery was complex with many moving parts that required maintenance. When IH engineers embarked on developing the axial flow in the 1970s, their goal was to simplify harvesting mechanics while increasing throughput and preserving grain quality, a challenge they met with remarkable success. The axial flow system worked differently. Instead of a threshing drum and walkers, the machine used a single, longitudinal rotor, a large cylinder that threshed and separated crop material in a continuous flow as it moved through the combine. This design eliminated the series of straw walkers and their associated mechanical complexity. With the grain flowing along the length of the rotor, the threshing and separation processes happened in a more streamlined sequence, enabling higher capacity and gentler handling of the crop. That meant less grain damage and fewer losses, two critical performance measures for growers harvesting high-yielding crops. The first axial flow models included the 1440 and 1460, and later variants like the 1480 expanded capabilities. These combines were widely produced at IH's East Moline, Illinois plant, with the 1460 being manufactured from 1977 into the mid-1980s. The rotary design gave IH a competitive edge because its patent protected a technology that significantly outperformed many conventional machines of the time. Farmers quickly recognized that the simpler rotor-based design required fewer drive components, reduced maintenance, and delivered smoother material flow through the machine, benefits that translated into real productivity gains during tight harvest windows. Number 6. Claas Dominator Series. Dominator Series. When examining farm machinery innovation by the decade, it's essential to include European developments alongside North American advancements. In 1971, CLA, a German agricultural machinery manufacturer, introduced the Dominator series, a family of combine harvesters that would become foundational for European harvesting operations. The Dominator name reflected a philosophy of setting new standards in combine design rather than merely iterating on existing models. The CLA's corporate history describes the early 1970s launch of the Dominator as a milestone that set new standards in international combine harvester construction. At a time when combine harvesters were evolving to meet growing global demand for output and efficiency, the Dominator series delivered meaningful performance advantages. The early Dominator machines were engineered to handle higher volumes of crop material with robust threshing mechanisms that improved throughput and grain quality. They were also built with an eye toward operator usability, recognizing that efficient harvesting depended not just on mechanical performance, but also on ease of adjustment, maintenance, and visibility for the driver. In this way, the Dominator reflected the broader 1970s shift toward making agricultural machinery both powerful and operator-friendly, something more manufacturers would emphasize in ensuing decades. One of the factors that made the Dominator series too good for its time was its role in consolidating performance and reliability in a package that European farmers, particularly those dealing with varied field sizes and conditions, could depend on year after year. In the 1970s, farms in Europe were more fragmented and smaller on average than North American operations, which meant machinery needed to be versatile and durable without sacrificing capacity. Claas's Dominator models addressed these needs while offering features typically found in more expensive or specialized equipment. As the decade progressed, later versions of the Dominator continued to refine cleaning systems, power units, and operator ergonomics, ensuring that machines stayed competitive with the rising standards of global combine technology. The lasting legacy of the Dominator series is evident in how it served as a platform for Claas's future combine innovations. Later Claas families, such as the Gleaner, introduced in the mid-1990s as an even more advanced harvesting machine, owe part of their design philosophy to lessons learned and capabilities proven by the early Dominator models. Although the Dominator did not invent rotary threshing like some North American competitors, it refined other elements of combine design, from efficient crop flow and residue management to operator comfort, at a moment when such integrated thinking was still emerging. Number 7. International Harvester 86 Series Tractors. While much attention in farm machinery innovation goes to harvesting and planting, the evolution of the tractor, the workhorse of every farm, also reflects key leaps in technology and design philosophy. In September 1976, International Harvester introduced its 86 Series Pro Ag line tractors, a range that included models such as the 786, 886, 986, Hydro 186, 1086, 1486, and 1586. What distinguished this series was not simply incremental increases in horsepower, but a thoughtful focus on the operator's experience, a shift that anticipated later priorities in tractor design worldwide. Prior to the 86 series, operator comfort and ergonomics were often treated as secondary to raw power and mechanical ruggedness. IH's 1976 lineup, however, introduced a new cab dubbed the Control Center, which came standard with features that were uncommon at the time: air conditioning, heat, and integrated radio and CB options. These amenities may seem commonplace now, but in the mid-1970s, they represented a significant departure from utilitarian designs focused solely on function. By making the cab a truly livable workspace, IH acknowledged that when operators could work longer with less fatigue and better situational awareness, overall farm productivity improved. Another technical improvement in the 86 series was the repositioning of critical components to enhance balance and ride quality. The driver sat well ahead of the rear axle, and the fuel tank was mounted behind the cab above the rear axle, a configuration that improved weight distribution and tractor stability during fieldwork. This emphasis on dynamic balance helped give these tractors better traction and reduced slippage under load, particularly with larger implements. The result was smoother operation and less soil compaction, two benefits that mattered as farms scaled up and heavier equipment became the norm. From a mechanical standpoint, the 86 series offered a range of horsepower options suited to a broad spectrum of tasks, from cultivation and planting to hay and forage work. The inclusion of hydrostatic drive options on some models, for example, the Hydro 186, further demonstrated IH's willingness to embrace advanced transmission systems that gave operators finer control over ground speed and implement operation. While these technologies would continue to evolve in later decades, their presence in a mid-1970s tractor family underscored how far ahead IH was thinking about integrated performance and user experience. In many ways, the 86 series foretold the modern tractor cab philosophy, a blend of power, comfort, accessibility, and control that recognizes the operator as central to field performance. It's no surprise that future generations of tractors built on this foundation, adding features such as ergonomic controls, improved visibility, climate control as standard, and digital instrumentation. These are now seen as essential, but in 1976 they were still emerging idea. The 86 series tractors were therefore not only powerful machines, they were vehicles that elevated the role of the operator, a change that became a hallmark of late 20th and early 21st century tractor design. Number 8. Gleaner N6 Rotary Combine. As the 1970s drew to a close, another major step forward in harvesting technology came with Gleaner's introduction of its N-Series rotary combines, beginning with the Gleaner N6 in 1979. This machine marked a significant industry shift. It brought the concept of a rotary threshing and separation system previously demonstrated by New Holland's TR70 and International Harvester's Axial-Flow into another major combine brand's lineup. What made the N6 noteworthy is that it wasn't merely a version of existing rotary systems. It embodied a distinct approach to material flow and separation that helped broaden the acceptance of rotary harvesting technology. Traditional combines before the rotary revolution relied on separate threshing drums and straw walkers, a system with inherent mechanical complexity and throughput limitations. Rotary systems, by contrast, used centrifugal force and a continuous flow to thresh and separate while moving crop material through a spinning rotor or transverse rotor setup. The Gleaner N6, along with its siblings N5 and N7, adopted this principle but tailored it to Gleaner's design philosophy, emphasizing efficiency and reduced horsepower requirements relative to older Walker combines. This allowed operators to harvest bulky crops at higher speeds with fewer stops and starts, translating into improved field productivity during short harvest windows. The way the N6 handled crop material was distinctive. Its rotor configuration encouraged thorough threshing, with less grain damage, while separation components minimized losses before grain reached the cleaning sieves. This attention to gentle handling and full extraction was particularly beneficial for fragile grains or high moisture conditions where minimizing breakage was crucial. In practical terms, farms adopting N-series machines often found they could maintain grain quality even at elevated field speeds, a real advantage when weather, labor availability, and yield demands all pressured harvesting schedules. It's important to place the N6 in the broader context of harvesting technology evolution. By 1979, rotary systems were gaining traction, but Gleaner's entry validated that multiple major manufacturers saw rotary architecture as the future. This competition helped accelerate innovation, leading to refinements in rotor design, cleaning systems, and cab technology through the 1980s and beyond. In essence, the N6 wasn't an isolated experiment. It was part of a broader industry transformation where conventional Walker machines gradually ceded prominence to more efficient continuous flow harvesting platforms. The influence of Gleaner's early rotary models can still be traced in modern combines that build on the core principles of high throughput, gentle crop handling, and integrated separation systems. While the specific engineering details of current machines are far more advanced, the N-series machines of the late 1970s represent a crucial step in demonstrating that rotary harvesters were not just viable alternatives, but superior choices for many operations. Farmers who chose these machines at the time were adopting technologies that would become mainstream only years later. Another clear example of equipment that was ahead of its time. Number 9. John Deere 8434 WD Tractor, 1975 to 1978. By the mid-1970s, farming was shifting toward larger fields, wider implements, and tighter working windows. Traditional two-wheel drive tractors were reaching their limits in heavy tillage and large-scale fieldwork. The John Deere 8430, produced from 1975 to 1978, represented a new class of machine built specifically for this future. As an articulated four-wheel drive tractor, it distributed power evenly to the ground, improving traction and reducing wheel slip under heavy loads. What made the 8430 too good for its time was the scale it anticipated. Many farms in the 1970s were still transitioning from moderate acreage to large commercial operations. The 8430 was already designed for a world where a single tractor would pull massive implements across hundreds or thousands of acres. It wasn't just more powerful, it embodied a new philosophy: fewer machines, each capable of doing far more work per hour. Today, large articulated tractors dominate broad acre regions, and their role feels normal. In the 1970s, that idea was still emerging. The 8430 arrived before many farms truly needed such capacity, but agriculture was clearly heading that way. Labor scarcity, fuel efficiency, and narrow weather windows made high-capacity field power inevitable. The 8430 was a preview of modern farming, built for the future before the future fully arrived. Number 10. Big Bud 747, 1970, Sueven. The Big Bud 747, built in 1970 Sueven in Montana, is unlike any other farm machine. It was custom-made for an operation already working at industrial scale, and later became known as the largest farm tractor ever built. More than its size, what makes the 747 remarkable is what it represents: a vision of agriculture based on extreme capacity. In the 1970s, most farms were still measured in hundreds of acres. The Big Bud was designed for fields stretching for miles, where productivity depended on covering enormous ground in minimal time. It could pull implements so wide that a single pass replaced the work of multiple conventional tractors. At the time, this approach seemed excessive. Few farms could justify such a machine, and the industry had not yet embraced farming at that scale. But the logic behind the 747 proved prophetic. As farms consolidated and acreage expanded, modern agriculture moved toward exactly this model: massive tractors, ultra-wide implements, and maximum acres per hour. The Big Bud treated farming like an industrial operation, optimizing time and labor through sheer mechanical capability. Though it remained a one-off creation, the 747 predicted what large-scale farming would become. Decades later, when mega farms and giant tractors became common, the Big Bud no longer looked extreme. It looked ahead of its time. These machines didn't age. The world aged around them. They outlived trends, technology, and expectations. Modern tools are smarter. These were timeless. Some machines aren't outdated. They're eternal.